And there, just to let you guys, I'm just looking at this right now. Okay, good. Welcome to the second phase of where we're at right now. We have today's anatomy and physiology, which I apologize. I think I got it out there late. I think I got it out there Wednesday night or something, or Thursday afternoon, or I forget now. But good morning, Valeria. Good morning, Anna. The Usually when we do anatomy physiology in a, I don't know, microbial physiology, human anatomy, whatever, pathophysiology sense, there you tend to take skeletal and muscle in a week or two, and then you do urinary in a week, and then you'll do cardiovascular, and the whole course is like this. So the what I did was, you guys, I've updated the PowerPoint, by the way, since I put it out there midweek, and nothing too crazy there, but it's interesting. And you'll see there that when we go over the PowerPoint there today, you're not going to really see. Hi, Shire. What can I do for you? That's great, buddy. I'm teaching, man. I love you. Can you close the door, dude? I love you. Bye. Bye. All right. Cutie patooties. You're not going to see a separation between cardiovascular system and respiratory. I'm kind of I teach in a holistic sense where you teach how, instead of segmenting the body into all these different distinct categories like respiratory, urinary, digestion, there has to be some fluidity. There are, an organ system, like what we learned there last week. There we went up from a cell to tissue, to organ, and then organ system, and then you put all the organ systems together and you have the body. Well, how I like to see things is that, yeah, sure, there's the cardiovascular system and there's the respiratory system, but you know what I mean? They work together. They have to. An organ system can't exist on its own. And every single aspect of this. And here, I'll show you guys here. Let's go to a screen share, shall we? Perfect. Da-da-da-da. And you'll see here that the integumentary system. I need some more coffee. My goodness. That's just a big, long, fancy word for skin. Skeletal, muscle, lymphatic, blood, cardiovascular, respiration, digestion, urinary, nervous. Nervous, I think I have like one slide or two slides there, not a lot. I didn't put in sexual reproduction. Even though, microbial infection and sexual reproduction, they go hand in hand. But I'll can't do everything. And I think that what we've done here, what we'll do there today, is a pretty good representation of anatomy, physiology, and just the whole idea that anatomy and physiology, anatomy is the structure, physiology is the what it does, right? And structure and function are absolutely tied together. And when we go through all these, keep that in mind, okay? And so we'll do this up here. I'll record this there, so you guys can have access it there throughout the week. Your quiz will open up there, I think, 3 or 4 there this afternoon. It's ready to go. It's 40 questions. I might knock it down to 38 and or so. Yeah, you got a week to do it. It's due before class there next week. I think it's 9 o'clock. And so you guys have lots of time. It's 40 questions. So what I've done is I've reduced the number of questions. Okay. And they hit all sorts of things here. Like last week and this week here kind of had an anatomy physiology flair to it. Week 7 and 8, they had a people flair to them there. We talked about case cards and surgeon preference cards and all, types of surgeries, these kinds of things. So The test is a good reflection of what we've done, and the quiz is a good reflection of what we've done, and next week's test will basically look exactly like the quiz, but I'm probably thinking somewhere around 50-55 questions. And the test there next week it'll start next Saturday and it will finish next Saturday. Okay. It'll open up, I think, at 9 o'clock in the morning for both classes, and it'll close at noon. Noon. Sorry, midnight. Somewhere in there. That's what I'm thinking. So you'll have a lot of time there. But next, so the quiz is open for a week because I want to give you guys the time to dig through the PowerPoints. And that's what all this is. And a good little function here. I don't know if you guys know it doesn't work on PDF PowerPoints, but if you have a normal PowerPoint like this one here, okay, where you can go in there and change it, and if you want to find something, let's say you want to find something on the liver, or let's say we'll find something on the lungs. Well, you go Control F. I'll do that again. Sorry, I can't show you how, but you hit the control button. It's in the bottom left of your keyboard, and then F. And this brings up this window here to find. And if you wanted to find something on the lung within the whole PowerPoint, see? And then it brings you to the first one. Is there any more? And then you can find the next one. Okay, more lungs. And the quiz and the test, I don't know, how do you say this? I don't want them to be stressful, but you're going to have to dig through the PowerPoints. And, if you've taken an anatomy physiology course, if you've taken something like this before, I don't think it's really that bad. The PowerPoint there for today goes into pretty good detail. Okay, but you don't need a master's degree. You don't even need a bachelor degree in biology to do this kind of stuff. This is I would give this there, to some. This is more of an introduction. Okay, and you guys have all taken your level of microbiology is substantially more than most. So that's where we're at right now. So the quiz will open there this afternoon. It's ready to go. It's around 40 questions. You have the week to do it. I also changed the style on the quiz as well. I got feedback. I listened to you guys. I tried to. And the last quiz there we did, only one question came up at a time, right? And then you go to the next question and then the next question. And I found that people were telling me there was kind of tedious. So what I did was I just opened the whole thing up. So it'll just your whole test will be there and you can go up and down and view it and all this kind of stuff. So everything should be good. I don't anticipate any issues. If there are, let me know. You guys are my eyes and ears on the ground, and keep me posted. I hope you guys are doing well. If there are any issues there, let me know. But I think you guys are on track, and I'm looking for a class average of even higher. Bring it on. Let's go 90. Let's go. All right. Do you guys have any questions at all? Is there anything there going on there that needs to be addressed? If emails have been kind of quiet there, and hey man, it's all good. You guys must have lots on the go, and I hope you guys are doing all right. But with no further ado, because we're probably looking at a good 2 hours here, so we may need to take a break and stop the video.
Ian.
Oh, hello. Hi, Jonathan. How's it going?
Ian, I want to ask you something about pathogen. I thought, when I said it was a microorganism that caused disease, how is it just an organism that causes disease, not microorganism?
A pathogen?
Yeah, because I was confused. It was not a microorganism.
I'm just trying to think of an example that's not a microorganism. But let me, I'll write this down. And Jonathan, can I, it's a pretty specific question. Can I ask what this is? Is this about a question on a test, or,
It's more like the quiz. It was kind of like a question that I thought it was a microorganism, but I just didn't understand how it was just an organism.
an organism is a microorganism. A microorganism isn't necessarily the same. It is an organism, but an organism doesn't necessarily have to be micro. A microorganism, you're only limited to micro. But um,
Oh,
the
okay.
let's follow up with this, Jonathan. We can chat after, or we can set up a time, or we can shoot me an email if this is about a question on the previous quiz. We can deal with that there, not a problem. But yeah, if we're okay, yeah, Jonathan, follow up with me on that, and we'll follow, and I'll get back to you, and we'll get back to everybody there.
Okay.
Okay, cool. The This is where we're at, and this is skin, bones, muscle, lymph, blood, cardiovascular, which is your heart, and veins and arteries and aorta and all this kind of stuff, respiration, digestion, urinary, and nervous. Now, please know that there are thousands of PhDs within each of these. And it's not my goal to test you guys on the level of an MD or a nurse practitioner or anything like this. We are taking a flat stone against flat water and we are just skipping. Okay? The whole point of this is I want to give you an overview of the cardiovascular system, lymph system, all these different systems. But we're going to keep it relatively simple. Okay? And have I ever taught the entire anatomy physiology in a day? Close. Well, let's go. And please feel free to ask questions or and keep me posted if there's any issues here. But yeah, this is going to be a good one. Let's have some fun. And honestly, this should be fun. This should be fun. Functions of the integumentary system. So this is your skin, okay? And the biggest organ in the body, and it is an organ. And basically, the definition of an organ is something that has more than one function, okay? And like if you look at bones, bones are structural, right? They provide protection, structure, okay? But they're also a library or a deposit area for calcium, phosphate, magnesium, minerals, these kinds of things. Like we just don't pee calcium away. We try not to, okay? We store it. When we have too much in the blood, throw it on the bones. When there's not enough in the blood, take it off the bones. You know what I mean? So this is basically the definition of an organ. There's multifunctions. And the skin there serves as a mechanical barrier, okay? Protects internal structures, participates in the immune response, okay? You get a red rash. Well, there we go, right? It's all part of it. And we'll get into that when we get into the skin. Acts as a gland for vitamin D synthesis. 20 minutes of sun is what you need. You got your daily dose of vitamin D. And please, in the wintertime, please consult your physician before doing anything that I say. Okay? But vitamin D supplement is a good way to keep your spirits up. Okay? And now we're coming into wintertime. We're fully clothed from head to toe, with only your face showing there in the wintertime. You don't get any vitamin D, so please make sure to get vitamin D. Skin is actually one of the major sources of excretion. And I don't drink myself, but the people who consume greater than normal amounts of alcohol, there the next day, their pores, they smell of there's the alcohol there in the air, and it comes from the skin. Okay, sensory role, and we'll get into where are the nerves in your skin. And you'll see that there's 3 layers of skin there that we'll talk about. There's more, but and also regulating body temperature. Like you'll see, like an elephant An elephant starts flapping his ears, man, get out of the way. I tell you, they're not happy if they do that. But also, you'll see there that there's a lot of blood vessels in like an elephant's ear, okay, and the elephant's ear is very thin, and that's how an elephant gets cooler. Okay, getting that hot blood closer to the air so that the heat can radiate out. Well, we kind of do the same thing there: body temperature, sweating, all these kinds of things. Here we've got this one here. I'm going to try and just put that down there somewhere. Can I move that there? Okay. There's three parts there to the skin. There's your epidermis, okay, which is thin outer layer. It's basically all dead. Well, it's not all dead. As you get closer up to here, it starts to keratinize, okay, and it starts to solidify, get harder, dry out. The whole thing there that we've talked about dust and all these kinds of things. I've read different reports there that anywhere between 50 to 75% of all dust that people sweep up off their floor is actually dead skin cells. And about every 6 weeks there, we slough off all of our skin and we have new skin. And so the epidermis there is the top layer. You'll see that they are stratified squamous epithelium. Okay, that should make sense. Stratified. Okay, squamous, short and flat epithelium there, and you'll see that there's your basement membrane, and that's where all these cells develop, and then they gradually, as more cells grow, the older cells get pushed up. And you can see that there's really not much going on. The dermis itself, this is a big one. Okay, thicker inner layer of the connective tissue. Blood vessels, smooth muscle, nervous tissue. You can see there that that's where the base of the hair follicle is. So there's no nerves in the top of your epidermis. So how are you feeling? I can feel things. This is my epidermis. How can I feel? Well, your nerves only go to your dermis. So basically what you're doing is you're kind of feeling the reflection of a feel, because there's no nerves up in here. There's only nerves down in here, right? You see all the stuff that's going on in here, okay? And then you have what's called your subcutaneous layer underneath. You'll see here, there, that's where the fat, okay? Major blood vessels, okay? And also called the hypodermis, okay? You got a layer underneath the dermis consisting of the areolar and adipose tissue. Adipose is just a fancy word for fat. Binds the skin to the underlying tissue, but is not part of the skin. And you'll see here, you got these dermal papillae up here. We spoke about them there last week, okay? And it's all about holding one layer onto another layer onto another layer, because when we fly our arms around, we don't want our epidermis flying off and hitting the wall, okay? And what is holding the epidermis onto the dermis? What is holding the dermis onto the hypodermis, okay? And all these ones here, see, you've got little pores. And again, we could spend days on just this. But what I have in these PowerPoints is what I'm looking at for you guys to not even know. You guys have to be able to find this stuff. And we've got 4 PowerPoints. So basically for this quiz, you're going to have 4 PowerPoints, okay? And you're just going to be digging around the PowerPoints, each question. I hope you guys are talking to each other, okay? Communicating with each other. Don't do this on your own. If at all humanly possible, do it with somebody. Why not? I'm a social learner, aren't you? However you want to do it, all right? But everything is in here in these PowerPoints there. I even put this one in here, burns. The whole idea of what a first-degree burn, a second-degree burn, and a third-degree burn are. And basically, it's just like a sunburn, right? It's really no, you're not removing the epidermis. It's just, a sunburn is more topical, right? That's one of the things, that's what we call a first-degree burn. Anything there that provokes damage onto the epidermis, that is what we call a first-degree burn. A second-degree burn, now we're getting down into the dermis. So a second-degree burn, the epidermis is gone. Okay? And you have to think there that with the epidermis here, with this whole process of keratinization, these are living cells here along the basement membrane protein here. Sorry, basement membrane, and they, as more cells are produced, these cells get pushed up. Okay, and they slowly dry out. The whole process of keratinization. Okay, they dry out. They become waterproof, waxy, which the whole point is there to stop microorganisms from getting in. Okay. And now a third degree burn. Now we've gone down even further, right? And that's the severity of getting a bad burn, is because now not only have you taken off the top layer, the second layer, even the third, like, you know what I mean? How do you grow that back? And in the process of growing it back, how do you maintain its sterility? Not even cleanliness, man. It's got to be sterile. And so that's why every hospital has a burn unit. Okay, because it's very serious. Okay. I put these guys in here. These are just some diseases associated there with the skin. You've got melanoma, skin cancer from the epithelial cells. Okay. Albinism, disorder there affects the coloring of the skin, hairs, and eyes. Okay. And animals there that are albino, like we had an albino hamster. Okay, basically no pigment. The eyes are red, and the skin is just not even white. It's more of a just, yeah, it's white. Okay, vitiligo. Some melanocytes lose ability there to produce melanin. Okay, melanin there. We use that there for coloring of the skin, helps you sleep, these kinds of things. Liver disease, cancer. There's a disease called jaundice. Okay, when the liver is I don't want to say failing, but when there's issues there with the liver, what'll happen is the liver will start to back up and won't be processing the blood as best as it should, and you'll start to see discoloration there, yellowing of the eyes, yellowing of the skin. That's called jaundice. Okay. Tumors of the pituitary gland, Addison's disease. Even if you eat too much carrots, you go orange. Okay, and that's carotene there. Cyanosis there, low O2 in the blood can turn the skin blue. Okay, typical there of hypothermia, pre-hypothermic conditions there in the wintertime there. The lips can go blue, these kinds of things called cyanosis. Alopecia, hair loss anywhere in the body. So there we go. You know what I mean? And this is the skin. I even put this in here. I thought that this was kind of interesting. Okay. These are just some accessory structures there to the skin. And you see the nail here. Okay. For the ends of your fingers and toes. And you have to think evolution, right? And our bodies are just a work in process. And a billion years from now, who knows what our bodies are going to look like. Okay. And our arms and legs are flailing out in the environment for billions of years, gathering nuts and berries and cutting down trees and all these kinds of things, right? And in the whole process, our fingers and toes are getting whacked against trees and hit by hammers and bitten off by, I don't know, feral animals, whatever. So over the course of billions of years, the body has come up with this idea here for these nails, and basically they're just extension of the skin. You'll see there that if we just go through all these different parts here, you'll have consists of the nail plate overlying a layer of skin surface. We call this there the nail bed. Okay, you've got your lanula. This one right here. You see, everyone's got them there. You know that little white part there? Okay, that's where the living tissue is. And just if you go back to this basement membrane here, the living tissue, okay, these living cells, they're created here, and they float up, and then they eventually keratinize and die and become part of the wall that is our skin and our protective layer. Well, it works the same way here with the nail bed. Okay, it's growing here. Okay, as new cells are produced, older ones are pushed outwards and become keratinized. Same thing, just as in other parts of the skin. Okay, just some interesting stuff there. And honestly, you have to think there. The quiz will be what, I don't know, 38 to 40 questions. The test will be 50 to 55 questions. These tests, they're not a true representation, and I can't go into crazy detail. You'll see that the PowerPoint here that we go through, in some slides there's some good detail, but on a test, can I really reflect the nature of the detail? No. And so I don't think there should be a lot of trouble there with the quiz and the test, and I hope that there isn't. And if there is, you guys will let me know. You guys have seen this there before. We showed you guys there last week. Here we have the axial skeleton. And you see, I didn't even put a title because I want a fluidity. I want a flow, okay, of all these different organ systems because they are connected, okay. The overview there of the skeletal system, okay, axial skeleton, which consists of your skull, okay, your rib cage, and your spinal column. Does not include your pelvis or your hip. Your appendicular skeleton here, this is more for movement, okay, it starts at the shoulders, okay, scapula there, your humerus down here, radius ulna, okay, here's your pelvic girdle, which then connects there to your femur, okay, there's your tibia, your little bone there on the sides called your fibula, okay, there for balancing, but that's what we got there. And you'll see here that there's a number of different kinds of bones. They come in all shapes and sizes, okay? You've got long bones, okay, which are, the femur, tibia, humerus, radius, ulna. These are your long bones here. You've got short bones, okay? In your wrist here, we have the carpals, okay? In the ankle, in the foot, we have the tarsals. Carpals, tarsals there for the foot. And they kind of work the same thing. There, your wrist and your ankle, there is movement for your wrist and your ankle, but then if you look at it, there's a lot of non-movement. Okay? Like your ankle there, you sprain your ankle, right? The ligaments there in your ankle, they hold that ankle in place. And if you sprain your ankle, you've stretched those ligaments. But we'll get there. We'll get there. There are flat bones there, like in the cranium. All right. And you have what's called irregular bones. There are weird ones. Like if you look at the bones there of the spine, which we'll have a quick look at. Okay. There's your manubrium there in your sternum. There's weird ones. There's little weird bones. Okay. Yeah. Let's go. So the skeletal system is composed of bones, okay, which we kind of hinted at there last week. You'll see a couple of the same slides again. Joints. Now, joints are these places there where bones come together. One bone meets another bone. And there's what we call an articulation. Articulation just means that two bones have come together. Now, there's a whole mess of different kinds of joints. There's sliding joints, all these kind of ball and hinge joints. I'm not testing you guys on that, on any of those, okay? But just a joint is just an articulation of two bones coming together. That's all it is. Cartilage, okay? We talked about cartilage there last week. Ligaments, okay? There's tendons, all these kinds of things, but we'll get there. Skeletal system there supports body weight. Absolutely. Supports and protects the soft organs. Absolutely there in the rib cage. That's their only purpose there. With the muscles there, bones can assist in movement. Okay, and I'll show you a slide there where the muscle attaches to the bone there. You'll see the point of origin and insertion there when we talk about movement. Skeletal system there in store. It's, as we said there earlier, it's just a library. It's just a depository of different minerals that can be removed at any time with your thyroid, parathyroid, hormones, these kinds of things, okay? Which I'm not getting into, all right? produces blood cells. Okay, long bones, flat bones there, that's where your blood is made. And just to tell you how connected these systems are, the blood is made in the bones, but the kidneys control the amount when blood is made. If there's a need for blood, the kidneys will tell you. And it's just incredible how all these organ systems, they do their own thing, but they communicate with each other. And there's two ways that they communicate: the nervous system and the endocrine system, which we'll talk about. Okay. Where are we here? Yes. The long bones here, and I'm just going into just showing you guys little bits and pieces here. Like, am I really going to test you guys on an osteon? No. Okay. But these osteons here, this is where the bones kind of grow, kind of like tree rings. But just for the long bones here, we have the diaphysis. Okay, this is the central portion there of a long bone. You've got the epiphysis and epiphysis there. These are just the ends. You've got an epiphyseal disc or plate. This is your growth plate. This is where it grows from. Okay, this is where the bone grows. It gets longer from there. You've got your medullary cavity. Okay, this is where the blood is made. This is the marrow. Okay, we've got the periosteum there, which is your outer covering, okay, of the bone. And you've even got articulating cartilage. Okay, and this is a big problem there with people there with arthritis. This cartilage here, as in your spine and your nose and all this, right? It's squishy, and it's supposed to be squishy. Because how many times have we whacked our nose? If our nose was just 100% bone, we'd all have broken noses. If you have a son like me, he's punching me in the nose daily. Even one time he stuck his finger up so far up my nose there by accident, went all the way up to the knuckle. So this cartilage here produces a cushion. And if this cushion, this is the articulating surface, the joint surface. Okay, and you don't want bone rubbing against bone. Oof, man, that painful. Okay, you want articulating cartilage rubbing against articulating cartilage. Okay, we talked about this there last week. There's two kinds of there's compact or hard bone, and then you've got spongy, okay, or soft bone. You can see it right here, right? And generally on the outside of the bone there, you'll have the your compact, okay, bone there. These are where the osteons are. But then towards the marrow, the medullary cavity, you have the spongy, soft bone there. Kind of resembles Swiss cheese. There's your bone marrow there. And as again, we're not really going into, like, I could do 80 slides just on long bones alone, but we're not. Okay. There's a couple kinds of fractures there that I want to look at. You've got the closed or simple fracture, okay, just a broken bone. And by the way, what bone is this? This is your pelvic girdle, okay, and this is your right femur. This is your tibia right here. There's your patella. There's your kneecap there. And just by the way, they're showing that this person here has broken their femur right in half. I don't think so. Unless you've been hit by a 16-wheeler truck. These femurs, they are designed not to break. Not to. If you've broken your femur, you have done something that is not done very often. Okay? But this is a closed simple. Okay, so just the skin is not broken. Just the bone is broken. So you come in there, reset it, and you should be fine. An open or a compound fracture here. Now the bone has protruded out throughout the top of the skin, so it's broken the skin now. So now we've got an infectious nature to deal with, along with the fracture itself. And the simplest of all the fractures there is the green stick. Okay, generally you'll see this there in children because um, children before the age of puberty there, their bones are kind of soft and kind of malleable. That's why I think we talked about this there. You should never, children who are prepubescent shouldn't lift weights. Okay, I've seen them on YouTube where you have these muscle bound 7-year olds. No, because their bones are going to bend, and because their bones can bend by lifting heavy weight on a continual basis, and then by the time they hit puberty, their bones will solidify, and now they will have bent bones. So there's 3 kinds of fractures. These are the irregular shaped bones here, and I just wanted to show you here the anatomy of the vertebrae. Okay, there are 3 sections. Okay, you have your cervical, okay, vertebra, which are up here towards the neck. Okay, you have your thoracic. Thoracic just means chest. Okay, we did that there last week. I enjoyed there last week because a lot of the words there that we learned there last week, we use commonplace there in this one. So you got your cervical, thoracic, and your lumbar vertebra. Okay, and you'll see here that it's all based on anatomy physiology. The structure is tied to the function. And you'll see here that the little guys up the top, okay, your cervical, there's no strength associated with these guys at all. Okay, you got your atlas, which sits on top, okay, and that's for your yes motion. You got your axis, which is number 2, which is responsible there for your no motion. Okay, they just sit one on top of each other and they allow for rotation. Okay, and you'll see that these guys here are just dainty little guys. And then you get into the thoracic. Now there's a little bit more, what I wanted to say meat, but there's no meat. There's a little bit more bone. These guys are a little bit more sturdier because these guys here, they have to support all of these guys here. All right, and you'll see there that there's other things going on. Okay, you'll have these articulating facets here for your ribs. The ribs come around and they attach right in here. Okay, and they have these spinous processes there. It's all about protection. Now, how much protection do we need? Well, it all depends. You go down here to the lumbar and you look at the lumbar vertebra. They are very, very different. Look at the body on these. These are massive. And that's why you see the lumbar vertebrae, they're for load bearing. Okay, these guys up here, the cervical, they're small, they're for flexibility. Think of them as kind of like the fingers, right? And then your thoracic, you got the ribs coming around. So you got these facets here. The spinous process is pointing down. It's all about protection. Really not so much about strength and load bearing, a little bit. You'll see that the thoracic vertebrae are bigger than the cervical. Okay, and then the big ones down at the bottom there, these are your lumbar. And you'll see there that these guys here, not about flexibility, not about movement. Your lower back shouldn't be moving around like this and that. Okay, your cervical, movement. Thoracic, there is movement. You got to have some flexibility in there for breathing, moving around. Okay, but the lower lumbar shouldn't be really any movement. And this is where a lot of people there, they get injured. Okay, and myself included. I was at the gym putting 100-pound weights back and just a rotation motion, and all of a sudden, and 6 years later, I've still felt it every day when I woke up. It's just one of those things there you live with. Okay. There are some curvatures there that I'd like you guys to know, some abnormalities there. And I've read on a number of different places there that a number of different papers and books there that we all have scoliosis there to some degree. And scoliosis is here, we're just talking about a left-right or a lateral movement of the spine. Okay, there's a curvature of the spine. could be to the right. In this case here, we've got a right shift, can be a left shift as well. Okay, every spine has scoliosis to some degree. This is extreme. Okay, you have something here called kyphosis there, which is the curvature of the spine towards the, here we're talking in the cervical, the thoracic region. Okay, up at the top. And then you've got something called lordosis, which is curvature there on the lower end. Okay, so scoliosis, kyphosis, lordosis. And you see, that's bones. That's where we're at. So the I don't want to go too deep into all of these because you could go so deep you'd never come out. Okay, we are just giving you guys a generalized overview. There are some specialized words there, but again, you don't have to memorize these things. All you got to be able to do is dig through the PowerPoint. And anyone there who just came late there, just a little trick to carry with you. Maybe you're not I'm not very computer inclined at all. Okay, in fact, computers and we have a very bad relationship. When they work, I love them. When they don't work, I don't love them. And but just to show you guys, if you guys ever wanted to find something within a PowerPoint, if you're looking for something on nervous system and you don't know where to find it in the PowerPoint, go to Control F and this thing comes up. And if you want to go kidney, and that'll tell you where kidney is. Go to the next one, goes through all of them. So now you really don't have to fret and worry about where something is in a PowerPoint. By the way, it only works on PowerPoints. It doesn't work on PDF PowerPoints. Okay? Because PDFs they're basically just pictures. Okay? I hope you guys are doing all right. I can't see if there's any comments, but let me know if you guys have any issues. You guys have seen these there last week there when we talked about cardiac muscle, smooth muscle, and skeletal muscle. Okay, skeletal muscle there, as you recall, we have control over. Okay, powerful but short-lived. Smooth muscle looks very different. Okay, this is your stomach, your small intestine, your blood vessels, these kinds of things. We do not have control over. They are not powerful, but they can last a long time. And then we have our cardiac, which tends to be a combination of the two. We do not have control over our heart, thank goodness. It is very strong and lasts a long time. Okay? We're just going to take muscles there a little bit further. Not too crazy, though. Okay? A skeletal muscle cell is also called a muscle fiber. Okay? Just the whole idea, like muscles. And we're going to go into a little bit what a muscle contraction is. Like, just the whole idea that here's your muscle, and in order for you to move and, all these kinds of things, your muscle has to contract and then release. Contract and release. And you think, how can they do that? Something at the cellular level is contracting, right? So skeletal muscle fibers are formed by the fusion of multiple myoblasts. Okay? Myoglobin. Okay? You have hemoglobin. Hemoglobin, as you recall, okay, this is in your blood, carries oxygen to all your cells, your big toe, all of this places. The muscles, they have their own myoglobin. Okay, they're not red blood cells, but there are these oxygen holding cells in the muscles already, because just the whole idea, like right now I haven't had breakfast yet, I'm just sitting here, I'm just having a cup of coffee talking to you, but all of a sudden if there's a bear right there and my life is in immediate danger, well, all of a sudden the adrenaline's going to kick in. My muscles already have a supply of oxygen and already have a supply of sugar ready to go. Okay, is it a huge amount? No, but it'll get you out of danger. So if you need to run for 2 kilometers right now, you can. Okay. There's They're striated, meaning they contain repeating functional units, and these are called sarcomeres. Let's have a look at them. Okay, the muscle tissue fibers there, they can be some of the longest of the body. You get into the psoas minor, the psoas major there in the leg, you can get them, they're massive, huge. Okay, held together there by connective tissue and enclosed in a fibrous sheath. Some fibers, they contract quickly, others do not. And it's just the whole idea that, I apologize there, maybe this will be a little gross, but meat that we eat is the muscle of the animal. And let's just take a chicken there for the time being. You have white meat and dark meat. And the white meat there is more primarily the breast, okay, which is not a muscle that is used a lot. Chickens really don't fly. And so if they do fly, it's for like 3 seconds and then they, fall back down to earth. So the white meat there, the breasts, you have the legs, the wings, the thigh, those tend to be the dark meat. Okay, those are the power. Those are the muscles there that are doing the power and always working. So, you're going to have some muscles that are fast twitch. You're going to have muscles that are slow twitch. Okay. Generally, the smaller the fiber, the faster its contraction. And of course, exercise can increase the thickness of muscle fibers. Okay, but you do not make more. And just the whole idea of exercise, building muscle. You're building your body is, it's very mean spirited, and if you have these big muscles, all right, or any muscle at all, and if you don't use it, I remember there in grade 10, I broke my tibia. It was actually a very, very bad break. It was a bad break. And I had a full leg cast on for 3 months. And always, I had muscle. I like to play soccer and football, these kinds of things. And at the end of 3 months, I had my cast taken off. And I didn't have a quadricep anymore. I didn't have a front muscle. Well, I did. But through the process called atrophy. Okay? If you're not using something, your body will take it away. And I hadn't used my quadricep for 3 months because it was immobilized under a cast. So now that my cast was off, my quadricep, the body had taken it, sucked it all away. And the whole point, the whole purpose of creating more muscle is your muscle fibers are these guys here. And if you work them too hard, what will happen? They'll bust. They'll break. Okay? And you have all these muscle fibers, and what the body does is, that's why after you exercise, you should take a day off that particular muscle group, or they say anywhere from 3 days to a week, because you busted those muscle fibers, and now the body has to repair them. And now because you busted those muscle fibers in that particular place, what the body does, makes more muscle. Well, if this guy here is going to keep busting this muscle, well, we're just going to make more muscle to fix it. And what happens is next week there, you bust those, and that's how muscle, grows. Atrophy, if you're not using a muscle, it will go. Here, we have this right here. No, good. I've broken this down into certain amounts here. And here we have the bone. There's your bone, there's your periosteum, right? That's the outer covering there of the bone. And if we can just follow this through, okay, here is your skeletal muscle. There's the tendon, right? Tendon attaches, muscle to bone, ligament, bone to bone. So there's your tendon right there, okay? And this is your skeletal muscle. And you see your muscle here, okay? What we've got are these fascicles. So this is a fascicle, a fascicle, a fascicle, a fascicle, a fascicle. All right? And you'll see here that on the outside of the muscle itself, we have what's called the epimysium. That's the covering your muscle. And if we take out one of these fascicles, you've got a paramecium. That's that cover. And if we take out what's inside these fascicles here, these are your muscle fibers. So you say, here's your muscle. We pull out these fascicles in here, and then we have our muscle fibers. Okay, and what I've done here, I've kind of blown it all up right here. Okay, so it's kind of the same thing twice. Okay, and then here are your muscle fibers. You pull one of these guys out, you'll see that these are what we call a myofibril. And then we can blow this up here. And these are these myofibrils here. You can pull, and you see what we have in here. These are these sarcomeres. Now, am I going to test you on, the chemical conductivity of these? No, I'm not. Okay, but I wanted to show you guys how these muscles contract. And if you have to go to the atomic level, and you'll see that these sarcomeres and these, and I've got them trying to just do this so I don't flip to the next slide. There we go. And you'll see that you actually have what's called a thick filament and a thin filament. Okay? And you have actin and myosin. And that's these bands. That's all these are. And they're touching, but they can move. And during a muscle contraction, okay, the nerve, your brain says, hey, I want to move my arm. So it sends a message from the brain to the arm. The electrical impulse there from the nerve goes on the muscle, disseminates onto the muscle, and contract. That's all. That's how muscles work. And am I going to go into the craziness of all that? No. I may ask you, what is the outer covering there of a fascicle? You would go in here, paramecium, there we go. But I'm not going crazy. I just wanted to show you guys. And you have to think, I've got a 40 question quiz going out there this afternoon. Is this really what I want you guys to take away? Don't get too caught up in all of this. It's more of a how-to, and I think you guys will get a lot out of it there. So things to note, outer coverings there. There's our muscle. Okay, within all these muscles, you have all of the fascicles. You pull out a fascicle there. The outer covering there is your paramecium. This is your epimecium on the outside here. Your muscle fiber here. Okay, we've got this. And if you pull out a muscle fiber, here are your myofibrils, and within the myofibrils are your actual sarcomeres. And yeah, can I spend 8 weeks talking about this? Sure. Am I going to? No. Just some words here that I've spoken about. I think all of them here. The fascia there, connecting connective tissue that holds muscle fibers there together, the muscle fiber. Origin and insertion. These have to do with movement, and they are... What just happened here? Something happened. Immovable. What did I just do? Oh, I think I know. Immovable. Sorry, guys. Something just happened here with my PowerPoint. Okay, good enough. And there we go. Perfect. Your ligament, your origin and insertion. These are opposite sides, okay? And it has to do with moving. So it's where the muscle attaches to the bone, okay? And the origin is the immovable part of the muscle that does not move. Your insertion, this is the other side of the muscle that exhibits the movement. Okay? Origin and insertion, opposites there. Insertion moves, origin, no move. Ligament there, that connects bone to bone. A motor nerve, we'll talk about that there later on there when we get to nerves there. Nerves and reproduction, I didn't really focus on too much. Those are the two, just to let you know. Sarcomere, this is the contractile unit of a myofibril. That's these guys here. Okay. Tendon attaches muscle to bone. This one here I like, tonus. And just the whole idea that your muscles are always able to fire. Even when you're asleep, there is a certain amount of tension in the muscles so that in the case that a bear does show up, your muscles are ready to go. Okay, so tonus there, when muscles are relaxed, there's always some myosin heads binding and releasing actin. So there's always a bit of tension in your muscles. Your muscles are never 100% relaxed. Okay, and here we go. We're off onto another one. Okay, maybe we'll do lymphatic and then we'll take a 5-minute or 10-minute break there just to keep you guys all going. The lymph system. This is a system there that gets overlooked a lot. You know, everyone knows about the cardiovascular system, urinary, bones, these kind of digestion, respiration. But lymph, this is something that gets overlooked a lot. And I just want to zoom out a bit there. There we go. What is lymph? And you'll see there, like my gram there before she passed away, she had special socks. Okay, and socks there that people put on there that, you know, maybe they have congestive heart failure, they have some type of a heart issue. The and the sorry guys. The so what goes on here is if you have some type of heart issue, all right, the heart can't pump the fluid, can't get things moving, or let's say you're not that physically active. There is a lot of things that are not in the cardiovascular system that can accumulate. And like you have a cell here and a cell here. Well, they're not the same cell, so there's a membrane and there's a membrane here. So there's two distinct cells separated by a membrane. Well, it doesn't matter how small you can get, there's still going to be things in between them. And we call this interstitial. And what interstitial means, it means in between cells. And the body is awesome, but it's not 100% perfect. Things can accumulate. Okay? And how do we get these things moving? We're not talking about things in the blood. You know, the cardiovascular system with its veins and arteries and aorta, it's got its roadways, blood is moving. But what about the stuff in between cells? You know, there's little bits of protein and plasma and sugars and fats and, you know, water and junk and all this kind of stuff. It needs to be moved or it just collects there, and we don't want it collecting. So lymph, what is lymph? It's a clear fluid that resembles plasma, composed primarily of water, electrolytes, waste from metabolizing cells, and some proteins that leak out of the capillaries of the systemic circulation. It's formed from the plasma during capillary exchange. So when the blood is exchanging things there with cells, some things get lost. And we like to keep things moving. And if the person or the patient isn't physically active as much as they should be, things accumulate down here. Why? Gravity. Okay? And it's the heart, it's the movement that keeps things moving. Oh, I can see my son there. He's going to need some help in a bit. But we'll finish off lymph and then we'll pause the video and we'll come back to it here. So lymph is this clear interstitial fluid that collects. And it's normal, okay? And you'll see here it's generally denoted in green, okay? And you'll see here that where this is your cardiovascular system, you can tell that these are your red blood cells here, okay? Blue denotes deoxygenated, okay? High in carbon dioxide blood, low oxygen blood. Red, okay? This is high oxygen blood, okay? And you'll see there that basically wherever there is a cardiovascular piece of apparatus, you know, capillaries, okay, you will see lymph. And it's there just to clean things up. Now, the heart is pumping the blood. There ain't nothing pumping the lymph. So how does the lymph get from down here back into the system? And you'll see there that it's movement. We'll get there in two shakes of a lamb's tail. Three main functions of the lymphatic system. Okay, it returns the interstitial fluid back into the blood, because the blood, you need that fluid back in there, because the blood needs the fluid, because you gotta absorbs fats and fat soluble vitamins. Okay, and helps the body defend against infection. There are you guys have heard of lymph nodes. Okay, like when people get sick, their tonsils will get swollen. Sorry, I don't know if you guys can see me or not. Your tonsils will get swollen there. You have lymph nodes here. You have them in your armpits, and you also have in your inguinal area, your groin, okay, your hips, right? Because your arms and legs are flailing about in the environment and coming in contact with things, so there's more chance of an infection occurring in your arms and legs, okay, than anywhere else. And if there's an infection in your arm, okay, well, that infection is going to travel down your arm, and it wants to get to the good stuff in your torso. Well, you have lymph nodes right here in your armpit. Remember those sniffer dogs? Okay, T cells there that are sniffing for infections. Okay, that's where they are. So that encompasses there the lymphatic system. Okay, drains the interstitial fluid parallel to veins. Okay, they're right in there with the arteries and the veins. Okay, wherever you see those guys, you will see lymph. Every organ in the body has a rich supply of lymphatic vessels. So this is all about protection. And you'll see here that the lymph, okay, this is how lymph moves through the system. As we said there, the heart pumps the blood, but what's pumping the lymph? Okay, and you'll see there that similar to veins, okay, you'll see here that the lymph vessels here, they have these valves. And let's say down here is my feet, up here is my heart. And we got to fight gravity, right? How do we fight gravity? Nothing's pumping up. We don't have a lymph heart. And what happens is through movement, okay, that's how this stuff gets kicked up. And what we call the skeletal pump. Okay, so you're moving around, you're walking, you're doing this and that, and what happens is this lymph gets kicked up to the next level and then hits. The lymph down here through movement gets pushed up here and then comes back down. Then you see these valves, they close when the lymph is in there. And then through more movement, the valve up top opens up and the lymph moves up. You see how it's kind of like this, all the way back up to the heart. So that's the best thing. So if you elderly people tend to have, thick ankles, they have to wear special socks because the fluid accumulates there in the ankles. Okay, that's because their skeletal pump isn't working as well as it should be because they're not as active, and well, they're elderly. All right, that's to be taken under advisement. So you just have a look here. There's your skeletal pump. Breathing is another one there that gets your lymph moving. Okay, that's movement. You're moving. That's keeping things going. And we have the rhythmic contractions of the lymphatic smooth muscle. Okay, vessel walls contract to push lymph along. Okay, so not too bad there. Okay, I would know skeletal pump. That's a good one. You just might see that one again. And again, lymphatic organs there. We've got lymph nodes, tonsils, the thymus, the spleen. You know what I mean? I'm not worried about these guys here. Okay, what I am worried about is that you guys understand what lymph is, how it works, in conjunction there with the cardiovascular system, because this is just basically fluid and proteins and all these kinds of things there that the body has forgotten about, and we need to kick it back into the system and get these things moving again. Okay, so this is called your lymphatic system. And you'll see here that there's lots of nodes, what we call these lymph nodes, and I'm not going into any detail. Okay, but these lymph nodes there, as we said earlier, there's a whole whack of them in the face. because your face has lots of holes, lots of places for infection, right? You have lots of lymph nodes there in your neck and your throat, okay? And you'll also have them, a lot of them there in your armpits and your inguinal area right in here, okay? All right, good. You guys have any questions, let me know. I can't really see the comments because, but I'll get to them there. Continuing on there with the lymphatic system there, we're almost done this and then we'll take a 5-minute. There's two kinds of immunity. And again, I could do a whole course on just this one, non-specific, but we're not. There's non-specific immunity, and there's the first line and the second line, and then we've also got something called specific immunity. Okay, so in a nutshell, the first line of defense here, what we're dealing with, non-specific. So I'm not really targeting one. I'm targeting all that I can. So you look at the first line of defense here, we've got mechanical and chemical barriers, okay? But skin and mucous membranes, mechanical barriers, okay? Your skin is designed to be waterproof, to keep the bugs out, okay? Chemical barriers there, you've got your stomach. In tears, there's actually a chemical called lysozyme, okay? That is an antibacterial, okay? These are your chemical barriers there. Reflexes, sneezing. You get a bug going up your nose or something like that. Well, it ain't going to get up there too fast because you've got a reflex there to sneeze. So these are what we call your first line of defense. Your second line of defense here, okay, phagocytosis. I introduced that word there last week. It just means Pac-Man, chomp chomp, okay? Inflammation. If a portion of your body, you can see some red inflammation, that means it's irritated. And we've increased the temperature there. We've brought more defenses there to that particular area. Okay. Fever. There's another issue as well. Let's say you have a fever, and you see the TV commercials there for Tylenol and Panadol and all these ibuprofen. Get your fever down. Yes, fever can be dangerous if it exceeds too high. But a fever is actually perfectly normal. It's your body's second line of defense against getting bugs out of there, because the bugs don't like a higher temperature, because a higher temperature means your body's working faster. We're getting more defenses in place. And when you take ibuprofen, when you take Tylenol, all these kinds of things, you're taking away your body's ability to make a fever. So you have to think, is that what you really want to do? Sometimes a fever could be a good thing. A little fever. But please consult your physician before attempting anything I say. Protective proteins, you got your natural killer T cells, these kinds of things. And so you've got your first line of defense, your second line of defense. This is all what we call your non-specific immunity. They don't care. They're just after any bugs. Then you have your third line here, what we call your specific immunity. Okay? These ones here, they remember. B and T cells. Okay? And you can see here I've got kind of a Men in Black from the movie there. Okay? What we call antibodies. Okay? Like you could even go into the Rh factor, the whole idea there that if a woman is Rh negative and she has a second child, you know what I mean? But we're not going to get into all these things. But I implore you, if any of these slides capture your interest, continue on and do a little bit of digging, because this stuff is just fun. And I just said there we can't go into any more detail. Okay. And the last slide before we take a break, the endocrine glands. Okay, I've only got one slide on this here, and basically the only thing I'm looking for there is hormone. But what I really want you guys to know is that there are two ways that the brain talks to my big toe. The fastest is nerves. Okay, if I pinch my toe, bang, within half a second, ow, that hurt. Okay, nerves, very fast, but they subside very quickly. Okay, their effects are strong, but they don't last very long. The other way that the brain talks to your big toe is through hormones. It's called the endocrine system. And these are what we call ductless glands. A duct, we're talking about a passageway through. So if something is producing a chemical and there's a path for it to be injected into somewhere, then this is not that's what we call an exocrine gland. I'm not worried about that. Okay, so these are ductless glands. They produce a chemical that just kind of floats into the bloodstream, widely distributed throughout the body, secretes hormones. Okay, onset of effects can be slow, so it can take a long time for these hormones to actually take effect. Okay, but once they do, they can be intense, overwhelming, last for days. Okay? And hormone here is a chemical messenger that influences or controls activities of other tissues, target tissues. Very important there. So, like parts of the brain there, the pituitary. And we'll go and have a look there before we take a little break. Okay? Well, you've got the testes there in the male. You've got the ovaries, okay, in the female. The pancreas there. It's actually an endocrine and an exocrine gland, but all these ones here, they secrete hormones. And all of these hormones are important for different reasons. You've got the parathyroid hormone right here, okay? It's on the back of the thyroid. This one here is involved in calcium reabsorption from the bones. You would think, what does this one here have to do with calcium reabsorption? But they are all very, very important, okay? So a hormone there is a chemical messenger that influences or controls the activities of other tissues. It has a target tissue. So when parts of the brain there send out a hormone, it's not for everybody. The hormone is released into the bloodstream and it travels around until it hits the target cells of the big toe or wherever it was intended. Okay? Ladies and gentlemen, we've got a long way to go. So what I'm going to do is we'll be back here at 10:20. I will pause the video. I will not pause the Zoom screen because I don't want to cancel it and have everyone ejected. So I'm just going to keep the Zoom going. I'm going to go on mute and turn off the video. Don't go anywhere. I'm going to pause the video and we'll see you back here at 10:20 exactamundo. Okay, bye.